All right. Got the recording going because apparently I have a child at home. If I don't do it, she nags at me about it. All right. Love you, Katie. All right. So talk about prop shafts or propeller shafts. That's the front of the crankshaft, the part that sticks out where the prop's going to go on. There are, in fact, different styles. We have the taper shaft. Taper shaft. As the name implies, it is.
Taper shaft.
I can't really get anything out of you guys, can I? I guess I want this one with, let's see, what do we got here? There we go.
Oh, there we go.
Nope. Slideshow. Where's from? Current slide. What did they do? There it is. There we go. Little taper shaft. And a spline shaft. Well, that's a taper shaft right there. It's got a keyway built into it. These are a lot of fun. I have a part that I just went to go get, but I loaned it out. And so, unfortunately, I'm sorry I can't. But I got to tell you this part. You can remember this story because it'll save you someday. If you're ever working on general aviation and you have to work on a tapered shaft, well, how the heck are you going to get a propeller on this tapered shaft? There you go, tapered propeller. No. So they don't make such things. So there is a, I thought I had a picture. There we go. There's an adapter that goes on there, and this adapter is tapered. That's the only one I got. That sucks. Okay. So that has got a taper on it. So you put this on the taper shaft, and you tighten this nut up right here, and it tightens the whole thing down on there. Now there's some things you have to know about that. What you can see back here, there's like another flange that the propeller is going to bolt through here. And by the way, the prop bolt's going backwards. They go from the back going forward, and the prop goes on, and then this little ring over here, which is a whole circle, goes on top of the prop, and that's the whole thing. So you can leave the whole taper shaft adapter on if you so choose and take the prop off, but I always recommend taking this off every so often because they tend to want to seize up on there. And there are rules and things about when you put these on, how you take this stuff called, and I'm really sorry that I loaned out my little shaft thing. Let me see if this is going to work. Hang on. What do I want? That. I like to pass it around. Tell you not to put your fingers inside of it. And then a little bit later, I explain to you what Prussian blue is. So Prussian blue is this blue ink, and you put it on parts. So what you do is, and there's a formula. You take like half of what you need, then you throw away 90% of that, and then you still have a little bit too much. And you take this Prussian blue and you ink, and you put it around the inside of this, and then you put it on the taper crank, and you tighten it down, then you take it off. And you look to see where the blue is transferred from this onto the shaft, and you have to have a certain percentage.
Yeah. That's the thing for like the dentist.
What?
Like when you go to the dentist and they're like chewing that little paper.
Yeah, that's not carbon paper, but same idea, exactly. So I pass it out, and you get a look at it, say don't put your finger inside, and then I say, now, let me tell you about Prussian blue, and then inevitably, it's always the person who never listens, go, I have blue all over me. I'm like, I told you not to touch the inside. So you do have to verify that you have a certain amount of contact area with that. But here's the funny part about it, and I was told this story, and I don't know how true it is, but it's worth telling. So this particular thing, it's, this nut locks it down, but what you can't see in this groove right here is a snap ring. It's a pretty healthy size snap ring. And most people don't know what that snap ring is for, but you're not going to be most people, you're going to know. This is a tool as well as an adapter, a tool to remove it. So the problem with anything that's tapered, once you put it on the taper, how are you going to get it off? I mean, it really takes a set, right? Well, so the story I was told is about some guys who, they said, well, flew somewhere to lunch and walking by this aircraft and had the taper thing on, and they could see the prop was taken off, and you could see a bunch of tools there, and they'd popped this little snap ring out, and taken the nut off, and you could see what they were trying to do, and You know, they had their lunch and left, and you know, then a week later they came back, you know, and there was more tools laying there, and a torch and a puller and all kinds of stuff, and you know, nobody was around. I don't know if that's a true story, but the point is, the snap ring is not supposed to come out. You leave the snap ring in, and then when you take the nut and loosen the nut, there's a flange back there on this nut that hits the snap ring. The snap ring then hits the groove that's in here, and as you start to undo this, it gets really tight. And what it does is, as you undo it, it pulls the entire assembly off. It's a puller, a built-in puller. And if you don't know that, you're never getting this off. So, and that is why mine is missing, because Phil was working with somebody who has a little taper shaft, and they couldn't figure out how to get this. Well, Phil knows. But I just walked by and I said, notice they'd taken the prop off and not the adapter. And I was like, well, you know, not getting it off. I'm like, well, it's because somebody took the snap ring out and threw it away. So I gave my adapter, and it has a snap ring, so you can take the snap ring out, but give it back. So now you know all about that. So it does have a very large key, a keyway that is built. So this is got a keyway right there, so you have a key that sticks in there, and that locks it all together so that it stays. So I've actually seen these keys sheared off clean, and it's kind of interesting. Yeah.
So looking at the propeller shaft and then the thing that came on there, where the bolt is supposed to go through, how does it go?
A bolt goes through what?
It looked like it though, on the hole.
Here?
Yes.
Yeah?
So
Here?
the big hole at the very top.
Right here?
Correct.
That's just for tools to go through. That's how you tighten it. You just put a bar through here.
Yeah, I'm wondering, how do you put the bar through the propeller shaft if there's no hole for that to...
Oh, the shaft is down. It ends about here.
Oh, okay. So that's... Okay.
Yep.
I'm like, it doesn't... Yeah.
Yeah, see it's right here, and so that
Probably
tool is
where that wave is.
somewhere out here, yeah. So, yeah, and then you see the little holes right there? Right there, those little holes? So, close. They line up here, and you put a pin through it. The pin goes from the inside out, so centrifugal force holds it in place, not safety wire. All right, so we got the taper shaft. See, has a large keyway. Has a large keyway. Has a large keyway. Obviously, if you had a prop strike, I'd just throw the keyway away. Why not write this? I'll write it now. So typically low horsepower. Only engines that I can think off the top of my head that had tapers were the A65s, 65 horse, and it's pretty rare, but I think a few 85s might have had an 85 horse, but it's really pretty much the 65s. Then we have, let me see, the spline. The spline. See if I can explain this one. All right, so you got the picture. So that's a spline shaft. And of course, if you were to look at a section of it, I don't want to draw the whole thing, you would see little, it's built like that. But symmetrical and nice. And so those are the splines. And there's actually tools where you can measure these splines to see if they have wear. And you wouldn't normally get wear unless there's movement in there. But the thing about these is there's what's called a blind spline, and that's really important. And sometimes the blind spline will have maybe just a screw or a bolt, but it fills in one of the holes. And that becomes what we call the blind spline. And so you can imagine you've got a matching prop hub that is going to go over that. It's blue. And the prop hub, of course, is going to have matching splines that go down in. Except, what are you going to do with this one? Well, that particular one is going to be missing a spline. So you have a section that's missing a spline on the prop hub. That's where that goes together. And that way they're indexed and clocked together. So you got to watch out for the blind spline. All right, spline shaft. So we have has a blind. So if You can't get it together, there's your problem. They do come in different sizes. Different sizes. According to SAE. In SAE, a Society of Automotive Engineers, numbers. So low horsepower this is going to be SAE, like 20 to 40. I'm not going to make you remember that. And high horsepower, SAE, 50 to 70. So all different sizes. And then, of course, we have the flanged, which you know because that is what you have. That is the most common. Most common on smaller planes. Smaller planes up to about 450 horsepower. You do have to be careful with the prop flange bushings. There's a lot to know about those bushings. You know, I obviously mention it when you're working on your engine. I mean, it's just something that you may have noticed. Oh yeah, there's bushings on the prop flange, and that's where the bolts go through. And for the most part, the engines you guys have, they've just been cobbled together and thrown on there. But these prop bushings are actually quite important. Let's see, what do I got here? Let's find a prop bushing. There we go. I'm talking about these right here. And most of the time, they are not the same. In fact, if you look at this picture right here, you'll see that they're not the same. This one sticks out, that one sticks out, that one sticks out. So these four are the same. These two are different. And what that does, it corresponds to usually something on the propeller. Sometimes one of them is a bigger diameter. So you'll have 5 that are the same diameter, or one that's bigger diameter, or maybe one that's a smaller diameter. And it's important to note that when you're putting this together, because what happens is often somebody will not realize that, and so they'll put the propeller on, and maybe this one's a little bit larger, or the way the prop lines up, they didn't have the right hole. And so what they do is, as they tighten it up, the prop has one, that's what it is. So one of these is trimmed down just a little bit, and so it's made to fit in a hole in the prop that's just a little bit smaller. Right? And so if you get it clocked off one, and now you got and say they're all sticking out the same dimensions. So you have the small one hole on the prop on the big bushing. Then what happens is when you tighten up all the bolts, it just pushes this one right out of the back of the flange. And so you see that. You'd be working on a plane, and you know, sometimes I note, especially on 4-cylinders, you can really note that it's in the wrong spot. I'm like, it's kind of in the wrong spot. And then you go around the back and see one bushing pressed halfway out. And so, yeah, so you got to make sure you get on the right one. There are service instructions from Lycoming that tell you exactly what the bushings are, where they're supposed to go. And props are clocked a certain weights, sometimes depending on the dynamic counterweights. Most 4-cylinders are the same. Most are the same. But anyway, it's important that you get it together correctly. Don't just assume. What do most people do when they take a prop off? You don't know because you haven't done it yet. So most mechanics take a marker, Sharpie, tape. They're very careful to tape everything exactly the way it came off, which can be a really good thing because a prop obviously is, it can go on this way or 180 out, which is almost the same thing. But if it's been dynamically balanced, it has to go on exactly the way it came off. But at the same time, you mark it, but you're responsible to make sure that that's the way it should have been put on. So in other words, you mark everything very carefully. You take off the prop, and there's several pieces of the prop. You got the spinner, then you got the front bulkhead, you got the back bulkhead to hold the spinner, you got the prop in between, you got all this stuff off, and you marked it all real careful, and then trying to find out you're clocked one hole off. Well, that's on you now, right? You need to make sure that it goes back on the right way.
Yeah.
Are props
dynamically balanced on the crank or off?
Dynamic means on the engine running.
Okay.
Static means off the engine.
So it could be, or could have been dynamically balanced incorrectly mounted on the prop, or on the.
Could have been.
Yeah, okay.
Yeah.
Then,
Not likely. Doesn't happen often, but could.
so if it was done incorrect and then balanced like that, would you have to then?
Yep. Then take all the weights off, have it rebalanced. You guys are going to learn. We have a nice balancer here. I haven't even used it yet. But you guys will get a chance to do it in second year. Learn how to do it.
It is really nice.
Yeah? You can do my plane for me?
Sure.
All right. So prop flange bushings, they're installed a certain way. Installed in a certain way. Certain way. I was just talking about the master bushing. Master bushing is different. Different and used to clock the propeller. Clock the prop. Where do you think you could find this information? How to make sure it goes on correctly? Manual? What manual? Overhaul manual for what? For the propeller.
The manufacturer's manual for the propeller?
The manufacturer for the propeller. Okay. Anybody else? You know. The engine manual. These are all good guesses. Something you have to realize about this whole system is when a propeller is made, there's a propeller manual and the propeller company, and they're all into their propeller. And then it gets sold to the engine manufacturer. I'm sorry, it gets sold to the airframe. So, you know, I got a Macaulay propeller, they sold it to Cessna. And I got a Continental engine, they sold it to Cessna. Cessna gets to decide how that stuff's going to go together. But interestingly enough, these bushing placements is in service instruction 1098 for Lycoming, because they'll tell you where to put their bushings. So that's bushings go. That's an engine manufacturer where they want the bushings. But ultimately, the way it's installed is up to the airframe manufacturer. Let me see. I think now I've totally screwed up my outline. Gonna skip something, so I'll remember for now, but I'll forget in a minute. Crank gear pad. Crank gear pad. What the hell am I writing? Pad. All right, pictures. What do we got? We got this from down here. All right, so here's crank gear pad. Now, it's nice that you guys have already started working on an engine, and maybe you remember how this goes. What goes right here? The gear. How is it held on? A bolt. A bolt. And what? What happens if that bolt falls out? Nope, there's no oil there. Okay, no gears are going to be rotating. What's that stop? Everything. Yes. Everything. Yeah. It's a bad thing, right? It's a pretty big deal. Although on top of the crank gear, it is the oil pump. So the oil pump kind of holds it down, which is kind of interesting. But once it's loose, it starts to work its way out. So this has caused quite a few problems. And for many, many years, it was just Lycoming had a problem. Then Continental joined in the problem, even though they have, I think, 4 to 6 back here, depending on the engine model. They just had a problem with some bolts. But here's Lycoming's problem that you need to know about. There's only one bolt. And, you know, it's never a problem until it's a problem, right? And so the problem became, and you guys are fortunate, you have the gears that they don't want you to use anymore. Your gear is a complete circle, right? And it's a complete circle, and it filled this all up. And you're really going to want to pay attention to this, because when you get to the instructions on how to do this, you're going to go, I don't understand these directions at all. So I guess I have to get rid of that and go to this. All right, so you have a gear that is a circle. And of course, it's got a little hole right there that lines up with that dowel pin, yeah? And then you've got, of course, where the bolt goes here. All right, so what happened is they were finding out that mechanics weren't paying attention, and they were just sticking this gear down on the back of the crankshaft, sticking the bolt in, giving it some torque, locking the tab and moving on, and the gear would maybe catch a little bit off to one side or wouldn't seat all the way down. Well, we now know that if you torque something and it's not really tight, what happens to that torque?
Null and void.
It's null and void, it's not torque, that gear starts rattling around, breaks off, and then the engine quits, and then the airplane falls to the ground. So they had to fix that, and so their fix was scallops. So they actually let you grind it out. I never did that, I just bought new gears, they're not that expensive. You would grind out these big scallops there. That just looks like a sad pirate now, but okay. And so now you're missing all of this material right here, like that, all right? So there was a method to their madness. My drawing's not very accurate. The scallops aren't quite that dramatic, but they're there. And so what they tell you to do, and you're gonna have to follow these directions mostly, is you're gonna take and you're gonna put the gear on. And then they're gonna, well, they want you to clean out the threads, then they want you to put the bolt in and measure the bolt to make sure the bolt's going down far enough. And then take the bolt out. Then you're gonna put the gear on, and they're gonna tell you to use a hammer, and you're gonna hit it. You're gonna listen. I keep telling you guys, use your ears. And they do you too. So you're gonna hit this, and you're gonna listen for a, and they describe the sound that's, I say solid, so you can hear it kind of resonate through the whole crankshaft. Yeah, that thing's really sitting hard. Right, then they want you to take a feeler gauge of a certain size, and I forget what it is off the top of my head, but it's very thin. It's like, I think it's the .0015, because it's the smallest one you get. And they want you to attempt to put it underneath these scallops. That is why these scallops are here, so you can get a feeler gauge down there. Now, what happens if you get the feeler gauge down there? Now it's not setting, right? So I get other students coming, I can't get the feeler gauge in. What do I do? Let me get my camera out. So, oh, that's right. I got a video to show you guys. Yeah. Is it okay?
Yeah.
Let me see. Wait a minute. I gotta see if it even loaded. I don't know. Let's see.
You know it's a good video when someone's already breathing out.
Well, how come it's not here? Oh, you got off lucky. Should be loading, right? I swear it takes forever things to load. Oh, look at it.
Is it in Drive?
3 years ago.
Aw.
There they are, picking out their engine. All right. Yeah, I have a bunch of stuff loaded. Okay, we'll get back to that. So you got to try and fit a feeler gauge. So should a feeler gauge go in there? No. Right, and then there's more procedure. You put the crank gear in and you tighten. This is the other place where people mess up. In the manual, it will tell you there are 2 distinct sizes of bolts. Off the top of my head, I don't remember it. I want to say one is a 1/2 inch and one is 1/4 inch. Next size up, 5/16. The problem is the small bolt takes the wrench size that references the big one. You know what I'm saying? So it's like if you have the small bolt, you have a 1/2 inch socket, and then the other bolt's a 1/2 inch bolt, which takes a bigger, it's something like that. And I want to say it's a 5/16 inch bolt. And so people screw that up and over torque the crap out of it. You know, when you bring me a bolt that's like short, it's like neck down, I know what you did. This won't tighten up, Kevin. Yeah, how much torque did you put on? So pay attention to the torque. So you push torque it down. Use food grade lubricant, which I think is mayonnaise. Somebody needs to taste that for me, tell me for sure. So they had a lot of problems, and you know, people died from this, and so you got to be careful. So I'll just make some notes here. So crank gear attachment is critical. That should go without saying. Crank gear attachment is critical. I mean, what is not critical, really? Critical. Lose the crank gear. Lose the crank gear. You lose the engine. Of course, you guys are mechanics and you're thinking about pilots, and you're like, well, that's kind of a you problem at that point, isn't it? Okay. I'll put this one. So crank gear attach, bolt, especially Lycoming, because it's only one bolt, is a one-time bolt. You torque it and remove it, throw it away. Don't, and this is where Kelly, especially Kelly, boy, if you're not honest with her, man, she will let me know about it, you know, and she's not, I shouldn't throw her, I don't mean throw it, I'm right behind her, but she just really brings it home and will tell you all the time, you know. It's hard being an aircraft mechanic sometimes. You make mistakes. We are human. That is the downside of being a human. You are going to make mistakes. I mean, I made a bunch of them. The thing you don't want to do is let one mistake become another one. So when you make a mistake, hey, I torqued this down, I accidentally over-torqued it, or, you know, my torque wrench was set for the wrong thing. I thought it was right. I just missed, you know, in Boston, I went over by 5 foot-pounds, or, you know. Be honest. Take it out. Throw it away. Yeah, sometimes the boss will be pissed. You know, I had to be in that position, and yeah, it kind of pissed me off sometimes, but then I would always have to just, you know, 5 minutes later come back and go, you know what you did was a good thing, you know, that you told me and did the right thing, and I'm really happy about that, and, you know, you're not in trouble. So make sure you do that. I have like an asterisk here. A 1/2 inch socket does not mean a 1/2 inch bolt. The wrench size is not the bolt size. Some of you people haven't heard me say that 100 times yet. I have a coffee cup that I drank out of this morning. It's on my desk at home that says the wrench size is not the bolt size. So I'm just going to get rid of that number 4 right there. The wrench size is not the bolt size. What is the wrench size? It's the wrench size of the wrench size. So obviously the crank gear drives all other gears. You just can't have a crank gear failure and expect anything good to happen after that. Crank to cam timing is obviously critical. It is very critical. I had a hard lesson this one time. So when I was a young man, I told you I came from the body shop world, and my parents had a body shop and a AAA tow service, and I was already in the Navy, and I was home doing something, and my dad called and said, hey man, you got to come down to the shop real quick. I'm like, well, I'm headed to the ship, I'll stop by on the way. So I stopped by, and some well-to-do dad bought his spoiled little daughter a Z28, and she put it in a ditch, and he stopped by the shop and said, she don't get it back. So if you know anybody who wants a slightly wrecked Z28, there it is. And so my parents said, you want it? I said, yeah, I'll take it. And I deployed, and I was gone for 6 months, and I just kept sending my paychecks home, and they you know, and I got home, and it was pretty cool. And I got home after deployment. It was in the garage. It was, you know, it was at 82, which was, you know, not the greatest Z28s, but it, you know, it was mine. And my stepdad, he had put candy apple blue stripes on it. It was a pretty sweet little car, you know, and it was all setting up ready in the garage for me. But there's a point to that. So anyway, it had an underwhelming engine in it. What was it? Had like the 5-liter.
What, yeah, the 302.
302, which had like a whopping like 170 horsepower, some stupid thing.
junk.
Yeah, it really was. It was just horrific. You know, it would go really fast eventually because it had this overdrive that would just, you know, if you waited long enough, you could get up to 100. Anyway, I'm telling you this story to tell you that
Sorry.
I had. So this is embarrassing actually. So I put in gear drive in it, the cam, because the cam was like nylon. So I put in a Pete Jackson gear drive, which is obnoxiously noisy and obnoxious. And so when we were putting it in, my stepdad was like, you know what? Let's wake this baby up, man. Because it came with spacers. And he's like, let's put a 4-degree advance on this camshaft. 4 degrees. So we put it all back together, and we lived, 10 miles from the shop. I barely made it 5 miles and back to the shop. It overheated the whole engine. Just that 4 degrees. And you can't see 4 degrees. I mean, it's just this little spacer that if you looked at it real close, you could just see it had a little bit more space on one side. It wouldn't even run. I mean, it was overheating and snorting and popping, and just like, so, if you're off by just a degree, you're gonna kind of know it apparently. So yeah. So anyway, the timing is critical, but unlike cars, it is so stinking easy to time these engines. It's just painfully easy. So you have the crank gear. I'm not going to draw the teeth, and it's got a mark on it, like on one tooth. And then you have an idler gear, and it's going to have a mark on one tooth. Well, I'll make a little tooth right there. I could have this backwards, I don't remember. And then over here, you're going to have a tooth, and there's going to be a mark in between the teeth. And then you're going to have your cam gear, and it's going to have a mark that matches up with that. So you just can't, I think I kind of screwed my drawing, but you just can't, anyway, don't draw that. I screwed it up. So the marks all line up. So that, I drew this one wrong, sorry. This one's got to be betwixt. So tooth, dots line up. All right, you can't screw that up. Now, what I do is I take some red paint, a red marker. I just had a little nail polish thing, and I put a little red on that tooth, and put a little red between those two, and a little red right there, and a little red over here. And yeah, I definitely have my drawing screwed up, but you get the idea. So I'm like, nope, that's wrong. But anyway, you get the idea. And I would put red on all the little, because it's barely etched in here. Yeah, it's hard to see. The engine could be tall for some of you. And I would do that, and so that it was just so painfully, blatantly obvious when it was together. And then I always have, and you guys have it too, you have a little check sheet, which is very similar to the one I had, and it says, cam to crank timing. And so I would sign it, and somebody else would say, look at it, and they would verify it, and then the accessory case would go down. And so I checked it, someone next to me checked it, because every time an engine doesn't start, the first thing they say is, you got the cam to crank timing off. Yeah. So, all right. So look for timing marks. Look for timing marks. It's really easy. Okay, I'm going to scroll down here. There is Lycoming does this. So I'm going to say Lycoming. Lycoming field trick to verify timing. So when in doubt, and by the way, they don't jump a tooth. This thing jumps a tooth, you got some significant issues, man. So you would put number one cylinder on TDC compression. I already told you guys this, but we didn't write it. All right, so what are the valves doing there in top dead center compression? Closing. They are closed and have been closed for a while. So the number 2 cylinder, which is the opposite side, so that would be the opposite front for you, is also on TDC, but on which stroke?
Exhaust.
Okay, so it just reached
Shop dead center, so both valves would be open, wouldn't they?
Okay, so let's go through it slow. So, what's that? No, it's top dead center. So number one has just gone compression, and now it's ready for power. So this one has also gone out, but it's the opposite. So what's the opposite? The exhaust. What's it getting ready to do then? Intake. Okay, so TDC, but it's on TDC. I don't put but. Let's just put TDC of exhaust about to be intake stroke. And then it says move prop, PRO, prop 5 degrees in each direction. So you move 5 degrees forward, 5 degrees back. The intake valve should just start to open when moved forward. And exhaust valve should just start to open when moved backwards. Make sense? So how much valve overlap do we have?
None.
Absolutely none. All right, what else can I tell you about connecting crankshafts? Obviously they're very, very expensive. I didn't really talk about the whole, well, I will now. So there's, they've had a problem with crankshafts, especially Continental. Well, they each had their problem. Lycoming had their problem with the SB 505 with all the pitting up in the front. That was their bad thing. And then they had some problems with this gear back here. Continental, I think, had problems with counterweights not being nitrided. But Continental's big problem became this VAR issue. VAR. So VAR becomes a big deal, and that stands for vacuum air remelt. And so what happened is they had a bunch of crankshafts, and I don't know a lot about this process. I suppose I should learn it, but I don't make them. I just work on them. And so I'm assuming from the name vacuum air remelt, when they pour the metal into the crankshaft, you can often get voids in there, or occlusions as it's called. And so by remelting it under a vacuum, you can pull out some of these impurities and make a more pure crankshaft. So what they had is some voids, occlusions, various spots in the crankshaft. And you can imagine that if it's not a solid piece of metal right here or over here, that created problems and the crankshafts were breaking. And so there was a big deal where you had to buy a VAR crankshaft. You had to get rid of the one you have. And I don't remember anymore what the time frame was. It became an airworthiness directive. But what is still in place is that anytime a 6-cylinder crankshaft is removed from the crankcase, which means you split the crankcase, and so anytime you split the crankcase, they want the crankshaft ultrasound inspected. So not only would you have to do a magnetic particle, but they want it ultrasound inspected, and it has to be inspected by somebody who's been specifically trained by Continental to do the ultrasound inspection on their crankshafts. And so that means that you got to send it out. So it's really a big deal to split the case on Continentals, because you can't just, if you had a crankcase issue, like, well, we're just going to take the crankcase off, we'll just set the crankshaft right there, we'll send the crankcases off, get them fixed, put it back together. No, you're not. You're going to be disassembling this whole thing, new rod bolts, new rod bearings, all that kind of stuff, because you got to send this out, get it all cleaned up, and get that done. But I don't think there's any non-VAR crankshafts out in the field anymore. I think there was a drop dead date. This has been like many years ago. So gotta have the VAR shoe. Airplanes are expensive, aren't they? Just keeps on adding up, and don't you love it? Lycoming or Continental makes a mistake, and what do they tell you to do? You guys just buy a new one. Sounds like a you problem. Oh, they do have a warranty and stuff. I shouldn't do that. If it's a factory engine, there's some warranty on it, and a lot of times there'll be a certain time frame where you can send yours in and get credit for a certain amount of credit. Of course, they don't usually pay for you to do all the labor and stuff. All right, where am I at here? All right, let's talk about. Let's see. Oh, talked about that. We talked about sludge tubes. Talked a lot about our counterweights. Can't really. I want to stress. I don't stress that counterweights. Working on counterweights, you got to be very, very careful and take your time and make sure those snap rings are really in there, and the plates are the way they're supposed to be. They're supposed to do all these dimension checks. They're supposed to be tight. I mean, you really have to do it, and I can't understate that. But then I think about the crankshaft gear. Like, well, I can't really understate putting that together. And then I'm like, well, what could I understate? What on this crankshaft can you just kind of haphazardly put together while you're talking on the phone and looking at your book face? And nothing. You got to be all in. All right, talked a little about radials. Let's talk about the connecting rods. Let's talk about paying attention. This is my favorite thing. Most of you guys have seen this already, but
Moving forward.
Oh, wow.
the guy who gave it.
I didn't see it at my angle. It looked like it was just slightly curved on the back.
It's a little bit. So the guy who gave it to me, Al, just the nicest guy in aviation. I wrote on the inside, Al, how much that cost you? And he said $27,000. $27,000. And I told, did you magniflex it? There are no cracks in this. It is split wide open, and I cannot find a crack anywhere. Told you they're soft. They're pretty soft. So what happened is they did a cylinder change on a Bonanza, and that's bugging me. Did a cylinder change on a Bonanza, and you'll find out there are many ways when you're working on your engine to do this. You could, to put this cylinder and all back together, you could take the piston and put the piston back on the connecting rod and have it hanging there, and then compress the rings, and then bring your cylinder up to it and slide it on. Or you can have on the bench your cylinder, and you can take your piston and put it in most of the way so the rings are in and the boss for the piston is hanging out, and bring the whole assembly up and pin it, and then slide it the rest of the way on. You follow? Either way is fine. Well, this particular mechanic decided that he wanted to do it that way, and while he's holding this is a big bore Continental. I don't remember if it was a 520 or a 470, but either way, there's reasonably heavy cylinders. He put the piston pin through the piston at about a position like that, missed the hole, and they started up the engine, and the engine just kind of went, and the piston didn't. Hammered the shit out of it. And then $27,000 later, I have a connecting rod. So pay attention. What time is it? Let's do it. All right. Connecting rods. Now, of course, there's a lot of stuff I tell you, but there's a lot of stuff I don't always have time to get into, and there's a lot more behind these parts that I wish I could show you. I'll talk as much as I can about it. So, Conrod transmits the force of the piston to the crankshaft, to the crank. To the crank. They are made of high strength alloy steel. They must be lightweight. This is what the guy at Lycoming said. You got to be lightweight because they stop, S-T-O-P, and change direction. Continuously. I don't necessarily agree with that. They kind of do stop and change direction, but they also don't come to a sudden and abrupt stop. They slow down. So when the crankshaft is at a piston pin, the that thing, the rod journal is straight up and down. Yeah, it's moving pretty fast, but then as it comes out and around, it slows down, comes to a complete stop, and then speeds up and goes back the other way, and then slows down. So yeah, it is starting and stopping a lot. I don't know how important the lightweight function comes in. I just wrote that because that's what they said. But they must be balanced. Must be balanced. Not all manufacturers are nice enough to give me numbers to work with. So I would always find, if Lycoming gave me numbers like this and Continental didn't, I would do all my engines to Lycoming standards. Whoever had the data, I would hold it to that data, which you can do. So balance should all right, get lost there, be 1/2 ounce, which is 14 grams or less, between opposing sides or opposite sides. Opposite sides. And that's for rods. And while I'm at it, I might as well tell you that 1/2 ounce, which is 14 grams still, or less, for pistons. And I got that out of TCM's manual, Teledyne Continental Motors, which is really not appropriate. Chapter 10, page 10-56. By the way, Lycoming, I always talk about Lycoming service bulletins and instructions. And there's also letters, which I explained to you the difference between them all. So bulletins and instructions are your important things. Continental used to be the same way. It wasn't a real thick book. And I really appreciated Continental service bulletins, like I said, because their manuals were more specific to each engine. So their service bulletins were relatively smaller. And working in the field, you kind of remember bulletins. You're like, oh yeah, we got to torque it. That's SB this, or you were gonna put there was a great service bulletin I liked for putting crankshaft gear seals in. It was this great service bulletin to tell you to put these cross hatches in the crankshaft, and a lot of information. And then one day it seemed like they just kind of stopped. And they no longer do service bulletins. They have the M-0 manual, which is called, did I write it? I saw that. Standard Practice Maintenance Manual. And so they took all the service bulletins and put them in a book, where it's really hard to find what you want. But it's there, and it's really thick. It's really frickin', it's a pretty thick book. So if you're going to be working on a Continental, you got to have both the Continental manual and the M-0 manual. Sometimes I call it M-O, but I think it's M-0. So that's what this manual is. You got to get the right manual. And I guess it's break time, so I will shut up.